Welcome again to the science class of gravitation of class 9 in chapter number 12, and this is a part 2 of 2. I am K.S. Chandra, PGT Physics, JNV SENAPATI in Manipur. Okay, now in this lesson, in this video, I will try to cover about thrust and pressure in a fluid and buoyancy, Archimedes principle of flotation, and lastly we will try to conclude with that of density and relative density of a substance. And in this lesson, when we try to discuss about this thrust and pressure, we will need to know the pioneering scientist, that is Pascal. Okay, this is a picture of the Pascal, Blaise Pascal. And now let's see directly to the thrust and pressure. Now this thrust and pressure is what? Your thrust is nothing but this is a force. What type of force? The perpendicular force. What perpendicular force? The force that is what? Experiencing or giving perpendicular to the surface of the body. We call it that as thrust. So now before going directly to that of the definition of this, let's go to that first, the practical activity that can be done. Now if you try to push a blunt nail, then it will be very hard to push inside an object. But if that need or nail or needle, if it is pointed one, then it can move this needle inside the other object very easily. What does it gives? It gives nothing but this is the pressure. Here the pressure is what? Low. But here if it is a pointed one, then the pressure is very high. So when a blunt pin is applied its force onto it, it doesn't go into the wood. Suppose if you take it a wood here, and if you take it a blunt nail or pin, then it will be very hard to push inside this nail onto the into the wood. Whereas if you take it a sharp pin, then it goes with the same amount of force, it goes inside this wood very easily. What does this show? Does the effect of a force depends on the area of the object on which it acts? Yes, it is dependent on the area, and that relation between the applied force and the area, we call it as what? Pressure. And that perpendicular force acted on to the body, we call it that as thrust. So let's see all about this. Now here I will give you more example also. Now you take a brick. Brick has different surface area. The surface area, when you keep like this, the surface area of contact is this area, the upper surface, right? So this is the having the largest surface area. And if you place it here like this, then this area this area will be little bit less. And if you keep it this onto this surface area, then it will be less. In this case, this is the least surface area of contact. What happened? The force that is nothing but its own weight, the force that is experienced by this brick due to the earth, that will be the weight. So the weight experienced here while it is keeping in this situation like this, or position like this, or like this, it will be having the same force or weight, you can say. But what happened? Their surface area of contact are different, right? So as the surface area is large here, pressure will be less. But as this is having lesser area of contact, it will be having larger pressure. So what happened when you move onto the surface of say ground? If the ground is sandy, then it will be difficult to walk if you wear a pointed heel shoe. But if you wear a broad sole shoe, then it will be easier to move. So this pressure depends on force applied. There is nothing here. In this case it will be weight, and also it depends upon the area, okay, over which it acts. That means area of contact. Got it? So what happened? Your pressure may be defined as what? The force acting perpendicularly on a unit area of the object. So we may define pressure as thrust per unit area. Thrust means what? Perpendicular force. Okay, or simply you can say like this: pressure may be defined as perpendicular force per unit area. So perpendicular force is thrust, that will be in the numerator, and area will be in the denominator. Okay, so your SI unit of pressure will be what? Newton per meter square. So your SI unit, that Newton per meter square, we call it in the case of what liquid and fluid, we call it as Pascal. Okay, that will be in the next slide. So pressure is a scalar quantity, even though your force or perpendicular force is a your vector quantity. This pressure will not be a vector quantity. Why? Because pressure is acted in all different directions. Okay, in the case of gas, in the case of liquid, rather we call it that as fluid. So what happened? Your pressure will be acted in all the different directions. Okay, so we will not take it that, okay, as a direction of pressure. So your pressure is a scalar quantity. Okay, and we call it that thrust per unit area as simply what? Pressure. SI unit given here. Okay, but your pressure is what? A scalar quantity, unlike that of your force or thrust. Now let's see some observation that we happen to experience in our day-to-day life. You know that school bags have white straps. Okay, if it is of a smaller or narrow strap, then we will feel pain, okay, to hang or to carry that what? School bag. What happened? Why it is made up of white strap? So as to have what? Less pressure. If pressure is less, then we will not feel that much pain. Okay, and now your sharp knife cuts better than a blunt knife. In the case of sharp knife, what happened? The edges is very fine. Fine means what? The area of contact, okay, will be very less. If area is less, then what happened? Your pressure will be large. If pressure is large, then it can cut easily. Okay, tips of a needle is made sharp. If the area of that tip is very small, then with the same force, what happen? It can easily puncture. Okay, or it can easily stitch. Okay, so what happen? That is also to have what? Higher pressure. Pressure of the ground is more when a man is walking than when he is standing. Okay, when he is standing, what happened? Pressure is what? Less, because the area of the sole of the foot, okay, will be more when it is more than when it is walking. When it is walking, what happened? The sole will be only with that of one sole only, not with that two feet. Got it? So what happened? It will be of that of one sole. The surface area of contact with the man and the ground while walking, it will be less. It will be of one sole only. So what happened? It will be having what? More pressure. Got it? Depression is much more when a man stands on to a cushion than when he lies down or sits on it. When he lies or sits on it, what happens? The surface area of the contact with the what? Cushion and that of the man will be more. Area more means what? Less pressure. Less pressure means what? Less what? Depression. Got it? And when it stands on to that cushion, what happen? Area of the two soles will be what? Very less when you compare with the surface area of the whole body. Okay, when it lie, okay, or sleeps. Okay, so what happen? Your depression will be what? More when it is standing. Suppose when it is standing, what happen? The sole of the man, this surface area, okay, it will be having two like this. Got it? The sole area, I mean this area. But when that man is sleeping, okay, like this, with the two legs there, okay, the surface area is very much more, right? So more surface area means what? Pressure is defined as perpendicular force divided by area. If area is large, then what happened? Pressure will be less. But if the force here acted onto the main will be equal to the here while at this lying position also. When it lie also, what happened? The same weight will be there. Mass doesn't change, right? So in that case of what? Standing here like this, your pressure will be more because its surface area is less. So surface area less means what? More pressure. When area is very large, in this case, what happened? Pressure will be small. So I am using what? Small p here and here capital P. Capital P means big P. If area is small, then pressure will be large. If area is large, then what happened? Your pressure will be less. So less area means what? More area means what? Less pressure. Got it? Yes, that is the example that we happen to find in our day-to-day life. So all these are the examples of that on the basis of what? Pressure. Okay, let me go to the next slide. I will not read all these things. Okay, now pressure in a fluid, this is the point to be discussed. Okay, the substance which can flow easily, okay, those substance which can flow easily and which doesn't have any shape, its shape depends upon the container, those substances are known as fluids. And those substances which can flow easily, which doesn't have any shape, its shapes depend upon the container, that is nothing but those substances are either gas or liquid. So these liquid and gases collectively we call it as fluid. Okay, like solid exerts pressure due to their weight, liquid also have weight and they exert pressure. Got it? Yes. Buoyancy. What happened? When buoyancy is a phenomenon of experiencing an upward force when an object is partially immersed or wholly immersed in a fluid. Either it may be on gas or it may be on into the liquid. You might have seen that in televisions that those paratroopers, okay, at a very high height jumping from the aircraft, okay, those paratroopers, they make different shapes, okay, of a ring. In the case of that opening of an Olympic game, okay, they will make 5 rings and all, they will float there above there on in the sky. Okay, so why that can be happening? Because of that buoyancy. So your air also gives that upward force onto those paratroopers, not only in liquids, okay, in the case of gases also it happens. Okay, so that upward force experienced by an object when placed inside the fluid, okay, we call it that as what? That phenomenon as buoyancy. And that force, upward force, we call it as buoyant force or upthrust. Got it? Yes. Now you will feel this phenomenon of buoyancy, but you may not recognize it. Suppose if you want to fetch water from a pond or from a river or from a tank, okay, then as long as your water bucket is in contact with that of the liquid, then you feel what? Lighter. Okay, but as soon as when that bucket is pull up, okay, full of water, pull up from that water, then you will feel heavier. Why? Because as long as that bucket is in contact with water means what? That water gives or push up a force known as buoyant force or simply upthrust. Okay, as the force is pushing upward, the bucket seems to be lighter. Same is the case also in the case of a mug of water. Inside the water appears lighter, but it feels heavier when it lifted above the water. Okay, that tendency of a liquid to exert an upward force on an object placed in the fluid, we call it that as buoyancy, right? Yes. Now what is this buoyant force? As I told you, that upward force we call it as buoyant force or upthrust. Okay, that is also called as upthrust or buoyant force, you can say it. Okay, that upward force experienced by an object when placed inside the fluid or inside the liquid, partially or it may be wholly. Okay, that upward force we call it as upthrust or simply buoyant force. What is these causes of buoyant force? What happened when a monkey is placed inside the water? The pressure from the sides are equal and no net force available. When a mug here like this, if it is placed inside the water, what happened? The force that is experiencing on all the sides of this mug, that will be all same, and they neutralize or cancel each other. But when this force from the upward and downward direction, these are not same because the level of the water may be different. And so what happened, the difference in force arises due to the level of water below or above it. So this difference in pressure exerts net upward force called upthrust or buoyant force. That means the force that is given here from the bottom toward the vertically upward direction, that pressure is more than the pressure that is giving downward here. So due to this difference in pressure, there will be a net upward force. And that net upward force, we call it as simply as upthrust. Now this is an experimental study to show you the magnitude of the buoyant force. Now if you want to measure an object like this in your hand with a spring balance, then it reaches say 60. So 60 gram weight is measured. And if you try to measure this like this, that means your measurement is measurement of the object in air. And if you put this object by bringing this spring balance above this water, and as soon as this object is in touch with the water, then what happened, this spring balance will read as 50 gram weight. This 50 gram weight, that means from 60 in air, it seems to be what, loss of weight. Lost by how much? From 60 to 50, the difference is 10. So 10 gram weight seems to be lost as soon as when this object is in touch with the liquid. So from where this loss come? Because your water gives that upward force onto this object. So that's why the weight seems to be lost. So we call it that as loss in weight. So that loss in weight, it is due to what? Upthrust or with that buoyant force. But if you immerse it wholly, if the body is immersed wholly inside this liquid, then again it further loses its weight. And that loss in weight, it is how much it is read as 40 gram weight here. So 40 gram weight means how much? The weight that is measured in the air is 60, and that measure when it is totally immersed or submerged inside the liquid, it is what? 40. So what happened? This loss in weight, it is due to what? Due to the upthrust or with the buoyant force, due to the buoyant force. This is the actual experiment that can be done in your laboratory also. Now let's see what factors affect this buoyant force. The magnitude of buoyant force acting on an object immersed in a liquid depends on what? Various factors. Volume of the object immersed in the liquid. In that previous slide, you might have seen that if it is only just touching the liquid, then it loses by 10 gram weight. But when it is totally immersed, it loses its weight by 20 gram weight. I will show you the previous slide again. See what happened when it touches slightly onto this liquid, it loses by 10 gram weight. When it is fully immersed, it is again lost by how much? This 20 gram weight. 20 gram weight means what? The upthrust is of 20 gram weight, and here the upthrust is only of 10 gram weight. If it is pushing with 10 gram weight, that 60 will be measured as 50. If the pushing upward is 20, then the loss will be how much? 20 gram weight. That is what it says. So it depends upon the volume of the object immersed in a liquid. More immersed means what? More upthrust will be experienced, and so there will be more loss of this weight. So the buoyant force depends only on the volume, but not on the nature of the solid object. This is very important. It depends only on the volume of the immersed part of the object inside the liquid. It doesn't depend upon the nature of the solid. That is, I will give you one example. If two balls of equal size but of different metals, okay, if they are immersed in a liquid, then both of them will experience the same buoyant force, okay, provided the immersed part is also same. Got it? The next is what? It depends upon the density of the liquid also. Liquid having higher density, okay, exert more buoyant force than that of the liquid having lower density. That is what you experience it when you try to swim in that fresh water. Then it will be difficult. But if you try to swim, okay, in the saline water, then as the upthrust is more, what happen? It will be easier to swim in the sea than that of freshwater lake, just like lake, okay. So here also what happen, even an iron block, okay, which sink inside the water will float, okay. This iron block will float in the case of mercury. Suppose if you drop this iron block in the water, then what happen, that iron block will sink. But when this same iron block, if it is allowed to place onto that of the mercury, liquid mercury, then what happen, it will float it. Because your iron, when you compare the density of the liquid with this object, what happen, density of iron is much more higher than that of the water. So if density of the object is more than that of the liquid, then the body will sink. But if the density of the object is less than that of the density of the liquid, then the object will float. So that is the case happening in the case of this iron block and the mercury. Mercury is having higher density than that of the iron block. So when iron block is placed over the mercury, what happen, iron block will float it. Okay, we will come later on about this also. Now let's go first about the Archimedes principle. This Archimedes principle is concerning about that loss in weight, or you can say about the buoyant force. Okay. Now Archimedes principle states that when an object is wholly or partially immersed in a liquid, it experiences a buoyant force. Okay. The upthrust, I mean, which is equal to the weight of the liquid displaced by the object. Okay. This upthrust will be equal to what? Equal to the weight of the liquid displaced by the object. Suppose if you immerse an object, then the level of the liquid in that container will be surely increased. That means the liquid portion, okay, that is displaced by the object, if you take it out exactly, then if you measure the weight of that displaced liquid, then what happen? You will find that that upthrust will be equal to the weight of that displaced, okay, liquid, and that displaced liquid will be also equal to the loss in weight. So you can define Archimedes principle like this, that is written here, or it will be a little bit longer, but it will be a comprehensive one. Okay, you can define like this. Archimedes principle states that when an object is wholly or partially immersed in a liquid, it experiences an upward force which is equal to the loss in weight, which is also equal to the weight of the liquid displaced by the object. Okay, so your buoyant force or upthrust will be equal to what? Weight of the displaced liquid, and this will be also equal to what? Loss in weight. This will be also equal to what? Loss in weight. Okay, in that previous activity that we have seen that the 60 gram weight which was measured in air, okay, when it is partially or fully immersed, what happened? It decreases by what? By 10 gram weight, and it is 50 gram weight. It is 50 gram weight. Got it? And when it is fully immersed, it was 40 gram weight, right? 40 gram weight. So the difference in this, that we call it as loss in gram weight, and it will be equal to 10 gram weight, right? That 10 gram weight, it is nothing but the loss in weight. This loss in weight will be also equal to the weight of the displaced liquid, and it is also equal to the upthrust. Got it? Upward force, that is known as upthrust or buoyant force. Okay, these three are related, and that relation given of these three, that is nothing but that is known as what? Your Archimedes principle. Got it? So your Archimedes principle states that when a body is partially or wholly immersed inside a liquid or a fluid, it experiences an upward force, and that upward force is also equal to the loss in weight, is also again equal to the weight of the displaced liquid. Got it? Let's see some application of the Archimedes principle. Archimedes principle is used in determining the relative density of a substance. We will learn about this relative density later on. Just you listen it, okay? Relative density of the substance. The hydrometer used for determining the density of a liquid are based on Archimedes principle. Okay, this hydrometer means what? It is a meter just to measure the density of a liquid. Okay, it is based on the principle of this Archimedes principle. Okay, and you might have seen, just to measure the purity of the milk, we use one device known as lactometer, and this lactometer is also used in the principle of this Archimedes principle. Okay, a lactometer is nothing but just to check the purity of the milk. Okay, now how much water is added in the milk? Okay, if that more water is what added with the milk, then what happened? The lactometer will show you that the purity is less. So your Archimedes principle is used in designing ships and submarines also. Okay, yes, let's go to the next part. Now see, why object floats or sinks in a liquid, that will be discussed first. Now, iron nail sinks whereas cork floats in water. I told you that when iron nail is placed in the water, then it will sink it. When the cork is placed above the water, then it will float it. Why? Because it depends upon the density. Comparison of density of this liquid and the object that is placed on it. What happened? Density of water is less. Density of the iron nail is more than that of the water. So what happened? Your iron nail will sink. But in the case of cork, what happened? Density of cork is very much less than that of this liquid. So what happened? Density of the cork being less than that of the liquid, the cork will float. If the density of the object is more than the density of the liquid, then it will sink. Got it? If the density of the object, I'm repeating again, if the density of the object is more than the density of the water, then it will sink. The converse or the reverse is also correct. If the density of the object is less than that of the density of the liquid, then it will float it. Then what happens if this density of the object and density of the liquid are same? No doubt it will float, and it will be there wherever you place it. If you place it on top of the liquid, then it will also float there. If you place it at the middle somewhere here, then what happens? It will be there at that position wherever you keep. Okay, if you keep at the bottom, then it will be there. Got it? Now next, let's see. When an object is placed in a liquid, two forces act on it. What are the two forces? Let's see. The weight of the object, okay, that is acting vertically downward, and the another weight is that is also vertical, but it is acting upward, that we call it as buoyant force or upthrust. Upthrust is acting vertically upward, whereas the weight of the object is acting vertically downward. So comparison of these two forces will make or will judge whether the object will float or sink. Okay, if that upthrust, for example, I will show you. Okay, now if a container is there like this, got it, containing water. Now you take it an object here. Now this object has its own mass m. So what happened? This weight will be acting vertically downward. That weight Wt or W, that will be expressed as mg. Okay, so this weight will be acting vertically downward, but the upthrust or buoyant force, that will be acting upward. So let me call it that buoyant force by B. In textbook you may find this as U, or you can call it as U. Buoyant force is denoted by U, and W will represent what? Your weight. So let's denote this as W. Okay, so comparing this W, one is pulling upward, that means your buoyant force is pulling upward, and the weight is pulling downward. It is just like a tug of war. Whichever is more, then it will move this object toward that bigger force. Okay, so if buoyant force is more, if U is greater than that of W, then what happened? The body will move upward. That means it will be the condition for float. Got it? If this buoyant force is less than that of the weight, then what happened? The body will sink. Got it? So depending upon these two forces, which one is more than the other, it will move toward the bigger force or larger force. But what happened when this buoyant force is equal to that of the weight? I told you that wherever it is placed, it will be there. Okay, that will be the condition when this buoyant force is equal to that of the weight. If you place it above the surface, then it will be there, floating there. If you place it inside the liquid, it will be there. It will neither float upward nor sink downward. Okay, that is the condition in this case. Got it? Yes. Let's go to that of the previous one. Okay, like this. That is what is all written here. Okay, so you try to pause this video and you can copy it down or you can read it. Whatever that I have said will be all here. Okay, let's go to the next slide so as to take not much time. Okay, principle of flotation. Whatever I have just said, that will be all coming here. Okay, an object will float in a liquid if the weight of the object is equal to the weight of the liquid displaced by it. So this is about that of your Archimedes principle. Okay, what is said? An object will float in a liquid if the weight of the object is equal to the weight of the liquid displaced by it. This liquid displaced by it will be equal to nothing but the upthrust. Okay, the Archimedes principle says that one, right? So your upthrust is equal to the weight of the object. That means the object will float. Okay, wherever it is placed, it will be there. Okay, a floating body may be partially or wholly immersed in the liquid. The liquid is displaced by that portion of the body which is submerged under the liquid. Okay, that will be giving you that much amount of the liquid displaced. More the liquid displaced, more will be the upthrust. Got it? Yes. So density of floating object. Now this is about the comparison of the densities of those objects with the liquid. An object will float, as I said, in the case of that of a Coke and water in that example. Okay, an object will float, okay, in a liquid if its density is less than that of the liquid. I told you that in that example, Coke is having lesser density than that of the water. So that what happened? Your Coke will float. So density of the object less than that of the density of the liquid, then that object will float. Okay, an object will also float in a liquid if its density is equal to that of the liquid. Suppose if that object is having the same density with that of the liquid, then wherever it is placed, it will be there. Okay, if you place it above the liquid, then onto the liquid, I mean, it will float. If you place inside in the middle, okay, in between that bottom and onto that surface, then what happen? It will be there, stationary there. Why? Because force acting onto them are also same. Density are same means. Got it? An object will sink in that liquid if the density of that object is more than that of the liquid. That is the case that is happening in the case of your iron object and the liquid water. Got it? In the case of that of iron and the mercury is having higher density than that of the water. So what happened? Your iron block will float in that mercury liquid. Okay. Yes, that is all given here. See, this is an iron block and this is water. So what do you expect? Water is having lesser density than that of the water. Yes, it will sink, right? But if this iron block, if it is placed, okay, onto this mercury liquid, into this mercury liquid, then what happened? It will sink. Why? Because density of iron is less than that of, it will float. I'm sorry. This iron block will float because iron has a lesser density than that of the density of what? Mercury. Mercury is having higher density than that of iron. So your iron will float in this mercury liquid. Okay. And now let's see about the floating of this boat in water. What happens when a boat is gradually lowered, okay, into the water? It displaces more and more water, due to which the outward buoyant force acting on it increases. Okay, so what happens? More and more Downward means what? The boat downward in the water means what? More and more water is displaced by the boat. So what happened? More and more upthrust will be acting on it. But the boat stops sinking further down into the water. Okay, why? Because it has its own weight and it has its own water to be displaced. So what happened? The two will remain same. That means the water displaced and that weight same. So what happened? It will remain there, okay, floating. Got it? Because the weight and the upthrust are same. Got it? It will not be sink, so it will float. Got it? Or rather you can say that if it is more by the upthrust, okay, than that of the its own weight, then what happen? It will float it. But if when the boat is floating, then the weight of the water displaced by the submerged part of the boat is equal to the weight of the body, just as I have said. Okay, when more people get into the boat, like this in this second case, when more and more people get into the boat will sink more. Got it? So more sinking means what? More water displaced, so more upthrust. But there is a limit, okay, what we call as what a prim soil line. This is the permissible maximum line. Okay, if it is below this, then what happened? This is not permissible and it may be what? Sink. Okay, the boat may be sink. So what happened? The more the weight that is placed onto this what boat, it may have up to this line, what we call as prim soil line. Okay, the level of the water may be up to here. If it is above this, then what happened? The boat may be what? Sink, or it may be capsized. Okay, as long as the weight of the boat and the people together is equal to the weight of the water displaced by the boat, then what happened? This will float. Okay, when no more water can be displaced by the boat, naturally it will sink, right? That is happening in the case of boat, right? Now let's see about density, and then we will quickly switch on to that of the relative density, and we will wind up our today's class. Okay, now let's see what is meant by density. We simply define this density as mass per unit volume. Mass per unit volume means you divide the total mass by its own volume. That we call it as mass per unit volume is defined as density. Got it? Mass is denoted by capital M, B total volume. So this mass per unit volume is known as density of the body. Got it? And so its SI unit will be what? SI unit of mass is kg, SI unit of volume is meter cube. So kg per meter cube will be the SI unit of what? Density. And in CGS unit it will be gram per centimeter cube. Okay, and this density is one of the characteristic property of that particular substance or material. So density of iron will be quite different than that of the what? Gold or silver. So if you know the density of an object, then you can certainly say that what material is that particular body by knowing that particular density of that object. Okay, so just like you have your own specific name and you have your own roll number in classroom, like that the density is also having what? A peculiar property that represents that particular material. Got it? So we can say that density of a substance is its own characteristic property, right? Now let's go to the relative density. Relative density is nothing but this is the density in compare with the density of some another standard substance, or density, relative density means in relation. Okay, this is a comparison in relation to the density of a certain standard quantity, and that standard substance or quantity is nothing but we take it that as water at 4 degrees Celsius. Got it? Density of water at 4 degrees Celsius is taken as what? 1000. Got it? So let's see, this is relative density may be defined as a ratio. Okay, ratio of density of the substance to the density of the water at 4 degrees Celsius. So we may write relative density RD as density of the substance ds to the density of water at 4 degrees Celsius. Got it? So we define relative density in terms of what? The density of the substance in relation or with respect to the density of the water. So by knowing the relative density of that object, we may simply say that the density of that substance is that much times of that of the density of water, we can say in that way. Okay, so let's see some of the values of the relative density of some of the non quantities or non what substance. Now you see coke is having the density of what, 240 kg per meter cube. So in centimeter gram per centimeter cube, you will have like this 0.24, but its relative density is what, 0.24. This means what, your density of coke is what, 240. Got it? Divided by density of water is what, 1000, as I said. So if you divide it, density of the coke divided by density of the water, how much you get it? So 3 zeros, so it will be what, 0.24, like this. That is what you are getting here. Got it? So that means this is what, your relative density of coke. Relative density of coke. So relative density of coke, okay, relative density of coke is equal to what, 0.24. okay, this means what, your density of coke is what, density of, let me write D only for density. Okay, density of coke is equal to what, if you know this relative density, then it will be relative density times the density of water. Okay, density of a substance can be expressed as relative density times the density of water. That means your density of the coke is 0.24 times the density of water. So if this factor is less than 1, that means density of water is more than density of that substance. Now you will see that density of coke is less than density of water, so it will float it. So what happened from this table, okay, if you look very carefully, then you will find that the density of water, from this water upward, say ice, wood, coke, these are all less than the density of water. Density of water is 1000. 1000 means 1000 kg per meter cube. Okay, that means in a, if you take a water of a cube shape of having the edges of 1 meter, 1 meter length, 1 meter breadth, 1 meter height, then it will be having the mass of 1000 kg. Got it? That is the meaning. So what happens when you take it, these all the substances above this water, ice, wood, coke, these are all having lesser density than that of this what, water. So this object will surely float above water. Why? Because density of object is less than that of the water, right? Now likewise, if you go downward, this glass, water and all this all coming up here like this with a greater density. Now you will find this mercury, okay, 13,600 kg per meter cube, and its relative density when you compare it divided by this by 1000, it will be what, 13.6. so relative density of mercury is 13.6. so your relative density is greater than what, 1. So that means density of mercury is much greater than that of water. How many times it is more than that of water? 13.6 times. Okay, so the density of mercury is 13.6 times than that of the density of water. That is the meaning of relative density. Now again, let's go to a very interesting example. Let's take it the example of that of what, iron and mercury. If you take a mercury, liquid mercury, it will have the same density, okay, 13,600 kg per meter cube. So when you compare this density with that of the iron, only 7,800. Now you will see the density of mercury is very much more than that of this what, iron. So what happened if you take it that liquid mercury and if you place it this iron, then iron is having what, lesser density. When you place this iron block in this mercury, liquid mercury, naturally your iron will float. Why? Because iron has a lesser density than that of the mercury. As when coke, of whose density is less than that of water, in that case also coke float, right? Same is the case here also. Density of the liquid mercury is more than that of the coke, or rather you can say coke is having iron is having lesser density than that of the liquid mercury, so it will float. In this case also the coke float. Got it? So your floating condition of floating depends on what? On that of the densities of the liquid and that of the body. When we compare it, what happened? If the density of the object is less than that of the liquid, then what happened? Your object will float. If the density of the object is more than density of the liquid, then what happened? It will sink. If the density of the object is same with the density of the liquid, then it will be there wherever it is placed. Okay, with that note, we will come to the end of our today's topic. Okay, thank you.